Welcome to ClickMyProject.com. Our project title is IoT cybersecurity on the use of a boosting based approach for the botnet detection. Our abstract is the rapid expansion of the IoT Internet of Things has brought about significant cyber security challenges, with botnet attack being to the critical concepts. To address this issue, machine learning algorithm, particularly boost-based approach, having shown to the promise is detecting and mitigation of the botnet intrusion. However, the selection of the approach algorithm play as a critical role in the achieving accurate detection and reducing to the probability of the infection. These articles focus on the utilization of the boosting based algorithm for the botnet detection in IoT environment. It evaluates to the performance 5 boosting based machine learning algorithm in the botnet binary detection, and then finding underscore to the significant potential of the boosting algorithm. The effective detection and botnet attack with IoT environment, the histogram gradient boosting algorithm achieving to the best performance for the binary detection with an the accuracy rate 0.99% of the accuracy. In the addition, temporal evaluation is present to the evaluate to the computational requirement of the each algorithm to copy with that resource contribution nature of the IoT. Our project flowchart is first we can start with the Anaconda Navigator Spider to launch with the bot IoT dataset. So we have applying to the data selection process. So after to the data gathering means we can move on to the data refiner. Data refiner is a data pre-processing step. Considering to the 3 steps, one is a missing values, label encoding and normalization method. After that we can extract to the feature extraction method. So what are the columns we can extract to the features wise. After to that we have split to the 80% of training and 20% of testing. After we are using to the model training algorithm, random forest decision tree, SVM, KNN and CNN model. Which model is the best one? We have compared with that our accuracy model wise. Finally we have predict to the which type of the attack, normal, probe, R2L, UR2 and then DDoS. Which type of the attack will be occur? We have predict to the model, and then we have calculate to the performance analysis, move on to the streamlet and end to the process. Our project execution based on, first we can read to the data set. After that we are applying to the pre-processing step. Next one is a label encoding. So after to the EDA plots, so these are the EDA plots. After to the model training, for the feature extraction part is the data splitting, random forest decision tree, KNN. After to that our proposed algorithm for the CNN wise we get the 98.67 means is a testing accuracy also we get the 99% of the part, and then we have calculate to the performance analysis for the comparative model, confusion matrix, classification report and compare with the accuracy part. Next one is at a home page. So streamlet wise this is a home page. We get the testing accuracy, training, precision recall, abstract, and then after to the prediction part we have entered to the details which type of the attack will be occur. We have check it on. After to the applying to the testing data. So these are the test data. We have analysis. The batch will be completed. So what are the data we have entered it? For example, we have entered to the these column of the data. So we have entered it and predict to the model is the DDoS attack will be occur. So the DDoS will be there. After that the batch normalization is completed means you want to the data set means is a prediction data will be there. So you can upload it automatically predict to the data model and show to that feature prediction part and show to the algorithm our model wise. So this is the whole process of project.